Hey there, Jeff Johnson here, Chief Design Officer over at Nested Knowledge. Today, I'm going to give you a brief overview and demonstration of Nested Knowledge as a whole, as well as highlight a few key features which I think you will find interesting. So first of all, Nested Knowledge is an evidence synthesis tool that's composed of two parts. So there's Autolit and synthesis. Autolit is the workflow portion. So we have various modules for searching, screening, qualitative and quantitative data extraction, and critical appraisal or risk of bias. And then everything you do within Autolit can be either entirely manual, you can come in and you can search, you can screen these things manually, or you can take advantage of some of our newer AI features to dramatically speed up that workflow. And then everything that you do within Autolit, however you do it, is reflected in synthesis, which is our visual interactive output portion of the software. So for example, search and screening yields you a Prisma diagram, and then we have qualitative and quantitative synthesis for quality to reflect what you've done in data extraction and kind of show that data in various ways and allow you to interact with it. And then we also have our dashboard and manuscript products to allow you to create custom views into that data as well. So let's dive into an example project that I just cooked up for this demo. So this is GLP-1 agonists for weight loss. I'm interested in that secondary indication for this class of intervention. And so let me get you a little bit better of a view here. So within this platform here, so now we're on the Autolit side, and I'm in Nest Home. This is the first module within Nested Knowledge. So here I could draft a protocol. I can also chat with my team. So Nested Knowledge is very collaborative. If I wanted to ask a question, say, about a particular record, I could do so here. You can also view the activity of this particular nest. You can see I've got some colleagues who've worked on this nest with me in the past. And also within here, if you're an administrator, you can see all of the settings to configure your nest to really adhere to whatever that protocol really is. From there, we're going to move on to literature search. And this is how you're going to want to pull records in to Nested Knowledge. Of course, like everything in Nested Knowledge, we have a manual workflow solution, and we do have some AI solutions to this as well. So I'll start with the manual solution first. Here, if I were a reference librarian, or if I were working with a reference librarian, and I had a Boolean search string that I could copy and paste in here, I could paste that in here, or I could write it by hand if I were so brave. But what I think I'll want to do instead, because this is not a very good query, is probably use our smart search feature, and I'll do that in just a second. So within this, though, if you had a good query, you can bring in records to a whole variety of different supported databases. So these are the ones that we can call out to automatically and import results on a schedule. And then you can also import, if you don't see your database of interest in that list, import from a huge variety of other databases as well. If you have a file of records that you want to bring into Nested Knowledge, that's no problem. So my search isn't very good, right? I need to make sure that this search is better. So I'm going to use our smart search tool because I am not a reference librarian. And it looks like I've already done this in this particular nest. So I'm going to actually hamstring this question a little bit, really just kind of make it a bad research question. And then I'm going to show you how you can refine your research question using our refine tools. So I'm going to give the system my kind of bad research question. I know it's bad. I know I need more information here to really capture what I'm interested in. So I'm going to use our system to help me figure out what that should be, and maybe it can sound the depths of my research question here and come up with something more interesting. So what specific health outcomes, it's asking, besides blood glucose control are of interest in this study? I'm really interested. I'm just going to chat with this, right? I'm really interested in weight loss, not necessarily, diabetes or that sort of thing. Maybe it can figure that out for me. So I'm really interested in weight loss is what I'm going to say. And then from there, we'll answer some more questions. Is there a particular duration of treatment with GLP-1 receptor agonists being considered? How about the first year? Are there specific subpopulations of adults with type 2 diabetes? See, this is the problem. I'm not interested in diabetes. That is, of course, the original indication for GLP-1s, but I just want to talk about weight loss. So I'm going to actually tell our system I'm not interested in diabetes, only weight loss. Oops, weight loss. Okay. But in terms of subpopulations, let's do men 30 or older, because I'm 30 this year. And then in the United States, let's see if it can help me kind of hone in on this particular population that I'm interested in. States. Anything else I should add? No, that's fine. No other comorbid conditions. Are there baseline characteristics of the adult population being studied, such as age range or severity of diabetes? I am interested in some other kind of baseline characteristics. Let's look at overweight as kind of something that I want to examine. Maybe BMI is something I want to just throw in there. And it's going to reinterpret what I've just said and kind of change my research question. Promoting weight loss in overweight men age 30 or older in the United States within the first year of treatment. That's a better research question. I'm going to save that. And then I'm going to generate a search strategy. So what our system's actually doing right now is it's going out, calling out to PubMed, and iterating many, many times on its search strategy. And it's actually mining the underlying search, the results of that preliminary search for additional terms in order to really scope the size of that search and the type of results in that search to my research question. So that's going to take a little bit. It's got to run those searches against the PubMed database, and it has to mine those results and then give me at least a preliminary search string, which I can then go off and do some other things with. Either I can accept it, just as it is, and finalize that search and bring that search into my nest, or I can kind of work with our system to explore that search further. So while that particular search is running, I've actually already done this. I'm going to go in and view recent searches, and I'm going to take a look at this search here. So this query one, you can see there's a bunch of different options. This might be a little big or it might be appropriate. I'm not sure, but I'm just going to start with this smaller one, and I could either finalize this and just bring it in as a search right now, or I can explore it in our search exploration tool. So I've hopped now from the literature search module into our search exploration feature. And what I'm doing right now is I'm going to run that search in a preliminary fashion. And now I'm going to be able to see a little bit of what the model is seeing. So it's going to extract a whole bunch of information for me, population interventions, comparators, outcomes, study size, study type, study location even. And it's going to give me some tools that I can use to craft a better search, or at least make sure that the search that it's suggesting for me is in fact going to return the appropriate results that I'm looking for, without including too many extra results. So I'm just going to let this run for a split second, and then once it's done, I'll kind of show you what that process looks like. Okay, so that's complete. And what I'm going to do now is I'm going to kind of just, well, first of all, let me orient you a little bit. So first of all, we have this create box. I can come in here, and I can add additional terms. So for example, I could add GLP-1 because I'm not seeing that in here. I can just manually add a term and change the number of results that are being returned by this particular search right off the bat. So these concepts can be ANDed, they can be ORed together, and all of that is going to change the preview of this Boolean logic that I will eventually finalize and bring in as my search. But if I want to explore the contents of this search beforehand, I can see the abstracts. I can read through them and make sure that they are in fact kind of what I was looking for. I can also see a frequency diagram of terms as they appear. So, and if any of these stand out to me as something I'm really interested in pulling in there, for example, body mass index, that's a mesh term. I could take a look at the entry terms for this, and maybe I can get really precise with this. I can create a concept out of that box or out of that term, and I can pull that in to kind of further refine my results and make sure that I'm capturing, BMI, but also the entry term for BMI as outlined by Mesh. And that's going to expand my search just slightly. Here you can see the number of results has ticked up a little bit, just because I'm making sure that I'm actually including anything that's referencing that and all of these other factors that I'm interested in. So whenever I'm ready, whenever I've actually refined my search, I can finalize this at any time, but I want to just march through these other tools as well. So you can look at the study type, for example. So we've got randomized controlled trials here. You can see some of these are randomized controlled trials. Some of these are observational in nature. You can see the location. So a lot of this research is being done in the United States. Got a little bit in China. Looks like 2 studies are being done in Brazil, which is cool. You can see the population size for these studies. So maybe you're interested in kind of getting rid of some of these epidemiological studies, for example, or maybe you're only interested in those ones. I don't know. You can do some topic modeling here. You can do acronyms if you wanted to make sure that you're capturing all of the acronyms that are related to kind of the definitions that we're seeing within this literature search. And you can view the frequency of keywords as well. So lots of options within search exploration. And once you're done, you can finalize that search and bring it in to the literature search module, and from there import a bunch of results. In this case, just to kind of show you another feature within Nested Knowledge, I think I'm just going to import some clinical trials using this exact query. It will work just as is. This is sort of an agnostic tool in some ways, though if you know a thing or two about clinicaltrials.gov, you may want to change a little bit about your search before you just run it on clinicaltrials.gov after refining with PubMed. But in this case, I just want to import a couple records here just to show you another feature. So Nested Knowledge, when you bring in searches from multiple databases, will actually handle deduplication for you. So I'm going to ingest, looks like 82 studies into this nest, and then you'll notice that it's actually deduplicating not just within these 2 databases, but across all of the databases, and automatically pulling all records that are exact matches out. And at any time, you can come in here and you can override that decision or modify the metadata or keep both or whatever for the records that are in your nest. So you really don't have to worry about deduplication in Nested Knowledge. And of course, if you have other records that you want to bring in, maybe you have a landmark trial you know needs to be included in your review, you can bring those in as expert recommendations. That's just the autolit portion, right? So everything that you do, as I said at the beginning of this video, is going to be reflected in synthesis. So that search process is going to show up in Prisma. And here you're seeing that clinicaltrials.gov database entry. We pulled in those 83 records, and we've also pulled in over 2,000 records from PubMed as well. Some of these have been screened. Some of these are still awaiting screening, and we have some other sources that can be brought in here as well. So from there, yes, that's literature search. It's always going to show up in Prisma. From there, we move on to the screening stage. So screening actually is a queue. You can screen, as I said, Nested Knowledge is a very collaborative platform. So you could screen with one person in Nested Knowledge or a whole team of 10 or more people screening and requesting records, and they won't be stepping on one another's toes. I can, with the click of a button, include or exclude, these articles for a whole variety of reasons that I can then configure myself in the configuration menu for screening. I can also configure how screening should be done based on my protocol. So we have really worked hard at Nested Knowledge to make sure that we can support whatever your workflow is. So whether it's single standard screening, which is sort of the default mode, or whether you need a more complex screening workflow, we support that within Nested Knowledge. So for example, I could set this nest up in a 2-pass screening mode. So you're going to do the abstracts and the full text first. That's very common. I could also require that each record be looked at twice. And then that's the dual mode. And then a third person is going to adjudicate any disagreements between those reviewers. And also, because it's nested knowledge, we're going to have a little bit of machine learning. We're going to have a little bit of AI to help you speed up that workflow. For screening, that's a screening model. We have an inclusion probability model that's going to train on your screening decisions. And you can do a couple of really neat things with that. So the first thing you can do is when you train that screening model, you can reorder records so that the records that are most likely to be included will be put first in the queue, and vice versa. The most likely to exclude will be left to later, which can really dramatically speed up your workflow. The other cool thing you can do, so now my nest is in a dual mode, that allows you to turn on Robot Screener. So I can actually have Robot Screener replace one of the reviewers within my dual setup here, and so then all of my entire review team can just focus on that one review. So it's almost like you are in a single mode, but that robot is still providing you with a higher level of accuracy. And if you're curious to learn more about screening, feel free to just reach out to me, and I'd be happy to kind of hop on a call with you and explain a little bit more about how our screening model works, as well as how the math works on when this makes sense for your particular protocol and your particular project. So screening, that's screening in nested knowledge. From there, you're probably going to want to move on to data extraction. We have 2 modules for data extraction. We have tagging, which is our kind of our qualitative module, and then we have MA extraction. Tagging is a similar kind of process here. So for this particular record, I can see that I can kind of extract various bits of information. So I can extract the population from this. I can extract the outcome, or any other concept of interest. I can systematically extract from this set of records, these 2,000 records that have been brought in to this nest. How do you configure this? You head over to the gear menu, and then our system will actually take a first stab at it. So what you're seeing right now is a hierarchy of concepts that has been generated by a whole host of AI features at Nested Knowledge. So there's 3 that are sort of relevant that I want to talk about here today. The first 2 are qualitative, and the last one is quantitative in nature. We have core smart tags here. So core smart tags can run on all records as soon as they are brought into your nest. And you can actually use this to kind of make some preliminary screening decisions if you want to. Or you can just use it as an extraction paradigm as well. So PICOs, study type, study size, study location can be extracted directly from title, abstract, and bibliographic information. And you can run this, and that is actually what you are seeing when I was showing you this part here. So from the abstract, I can get the population, and here it is. It's highlighting that type 2 diabetes population. And it gives me full provenance as to where that concept is appearing in this text. Core Smart Tags only runs on title abstract. However, we do have adaptive smart tags as well. So you can create your own custom questions, and you can ask whatever questions you want of all records within your nest, either at the abstract or the full text level. And you're still going to get that data provenance. You're still going to get the annotations within the text, whether it's full text or whether it's the abstract, as to where our system is finding that information for you. And from there, you can really go in and you can correct any of those decisions if you want to as well. So for example, if this one were wrong, if this population were wrong, I could modify this. I could change where in the text that appears, and then I can update this and change it. It's not wrong, so I'm not going to do that. But yeah, that's how qualitative data extraction works in our system. And again, this is a little bit complicated. So you can run the core smart tags yourself, but if you want help running adaptive smart tags or help configuring a custom hierarchy, again, reach out to us here at Nested Knowledge, and question, we'd be happy to kind of hop on a call and show you how that works. When you are done with qualitative tagging, of course, we have a synthesis module for that as well. So here you can see this is a sunburst diagram of included studies, which you can start to examine which of these studies are reporting GLP-1, for example, and how many of these studies report both GLP-1 and obesity within this set of included studies. So this is going to give me a sense of which of these studies or which of these records within my nest are reporting my concepts, the concepts that I am interested in, as well as any other concepts that may also be appearing in this literature. So that's how qualitative synthesis works. Quantitative synthesis is available as well. So what you're seeing here was also generated by our AI system. I'm going to show you how that was configured. So this is also a queue. You're going to come in here and you are going to source your full text. In this case, for this particular record, I don't have one, but you're going to source your full text, and then you are going to probably want to run our smart MA extraction feature. This feature takes your research question and then takes the full text and attempts to extract a bunch of different things. So what you're seeing here is this intervention hierarchy, this purple hierarchy, which if I zoom in a little bit, you're going to start to see will extract interventions and comparators down to the dosage or arm level. And then the other thing that this feature generates is a series of data elements. So these blue tags are qualitative, but as I zoom in on these gold tags, you're starting to see some outcomes and key data elements and variables that I want to extract. So body mass index is key. It's going to properly configure my form, and then it's going to extract that information, at the study level. So if I then head over to synthesis and I take a look at my quantitative display here, you can see if I zoom in on these GLP-1 receptor agonists, I expand those, I can take a look at the one study it looks like that reported tirzepatide here. I can click on that and find where in the full text that data is reporting, or is being reported. So body mass index looks like it is found in this table somewhere. Yep, there it is. So that's nested knowledge kind of in a nutshell. You can search, you can screen, you can extract qualitative and quantitative data, and it's going to be nicely visualized for you within our synthesis tool. And of course, you can export that information for further analysis as well. Let me know if you have any questions, though. We would love to talk to you. If you're curious, we can give you a more in-depth demo. We can explore one of your research questions instead of just this generic research question that I kind of came up with on the fly. Feel free to reach out to us or try it out for yourself. You can head over to nested-knowledge.com and sign up for a free account. Thanks so much for taking the time. I know this video got a little bit long, so if you're still with me, thank you so much for your interest. We'll hopefully talk soon.